Let's try to solve another Leetcode problem. Sorted paths in a grid with obstacles elimination. So the problem is that we are giving a grid. So inside the grid 0 and 1 means obstacles and 0 just means an empty cell. And we want to go from the upper left corner to the lower right corner. And we have a limit, and this limit is the number of obstacles we can go through. So for example, for this first example, k equal to 1, this means there's only one obstacles we can go through. So there's going to be a path like this from here, here, here. Yeah, because we can go through one obstacle, so definitely. So how many steps? 1, 2, 3, 4, 5, and 6 steps. So we're going to return a 6 because we're going to return the minimum steps we can go from the upper left corner to the bottom right corner. Yeah. So it seems this problem can be solved by using a BFS, because BFS is used to solve the unsorted path problem. Yeah, but the difficult part is about there is obstacles, and we have to record the number of obstacles. Yeah. For this example, at most we're gonna have k equal to 1 obstacles. It means we can go through one obstacles like that. Yeah, or we can go one obstacles from here or here, but the path will be longer. We're gonna calculate the sorted path. Yeah, so I think the only difficult part is that we need to have a weighted set, and inside the weighted set there's gonna be R and C. It's gonna be the positions, and also we need to have another record. So it's gonna be the number of obstacles, because yeah, so I will keep O. So this O means the number of obstacles. Yeah, because we want to keep the record of the obstacles. So for example, k equal to 1. So this means the number of obstacles should always be less than or equal to 1. Yeah. Now, if we want to go to this cell, it can have different directions. It can go like that, or it can go through this wall, or it can go through this wall to here. Yeah, definitely there are a lot of combinations. So that is why we need to have a record of RC. It's going to be the positions and also the number of obstacles inside the weighted set. Yeah, after that, I think the problem is going to become easier. So if we want to go to the bottom right corner, we just need to use BFS to go to this position, and also we need to keep the number of obstacles should always be less than or equal to k. So if we can go through here, go to this position, and also the number of obstacles is less than or equal to k, and we just need to check how many steps, maybe 6 or maybe 5. We just need to return the number of steps. Yeah, now let's just use this idea to solve the problem. Yeah. So we're gonna prepare, let me prepare RC. It's gonna be the length of the grid and the length of the grid 0. And let me prepare a directions array. Yeah, so this is going to be just for directions. You can write as you like, but I prefer to use this kind of array representation of 4 directions. So minus 0 and 0 minus 1. Yeah. Now I also need to have a weighted set, as I said before. So the weighted set gonna be 3 dimensions. It's gonna be R and C. It's gonna be the first position 0 and 0, and then the number of obstacles. But how to record the number of obstacles? Yeah. So we are starting from the top left corner at this position. So it can be 0 or 1. Yeah. So this means if it is a 0, so if this grid RC equal to 0, otherwise, so the number of obstacles from the start position is going to be 1. So we're going to record a 1. Yeah. But before that, we have to check. We have to check that if this can be an obstacle or not. If this is an obstacle at the top left corner, and our k is equal to 0, it means we should not have obstacles. So we're going to return a -1 immediately. So we're going to have a check before that. So if grid are 0, 0, let's just use the top left corner. Yeah, equal to 1, and the k equal to 0. So this means it is not possible. Otherwise, it's going to be possible. And also, we're going to need to prepare the queue for the BFS. So inside of the queue, it's going to be the same. So the position is going to be 0, 0, and the number of obstacles So we just need to copy, yeah, this one. So it's going to be 0 if the grid rn 0, 0 equal to 0. So here going to be grid 0 and 0. Yeah, let me just change that. It's going to be 0, 0. Otherwise, we're going to record it as 1. And we also need to have the number of steps. So inside from the beginning, so the number of steps is going to be 0. Yeah, let me just prepare. It's going to be RC obstacles and the steps. Yeah, so this is going to be the 4 dimensions for the queue and 3 dimensions for the visited set. So it's going to be RC and obstacles. Yeah. Now I think we are safe enough to go for the DFS. So we're going to check the queue and we're going to pop out everything. So everything going to be RC, obstacles, and steps. Yeah. So it's going to be equal to q.pop left, as I always want to pop it from the left side for the DFS. Yeah, for this queue. And now I want to check the 4 directions. So it's going to be dr and dc inside the directions array, and I'm going to update the row and column. Yeah, it is going to be just r plus dr and c plus dc. Now I want to check if the row and column is inside the boundary or not. Yeah, so first I want to check it must be inside the boundary for the row and column. Yeah. Now I want to check if it is inside the weighted set or not. So the row, column, and the obstacles. Yeah. So if it is not inside the weighted set, so what I'm gonna do? I'm gonna put it inside. Yeah. It's gonna be the column and number of obstacles. Yeah. So after I put it inside, what should I put it inside of the queue? Because at the moment I need to put it inside of the queue. Yeah. So maybe I just want to check. I want to check the grid with row and column. Yeah. So if the grid row and column yeah. So if the let me think about it. Maybe it is wrong. Yeah, so if it is not inside of the weighted set, I would to put it inside of the weighted set, and then I would to put it inside of the queue. Yeah, so if grid row and column equal to 1, so queue should append the row, column, and obstacles should plus 1. Yeah, because this is an obstacle, and the steps gonna also plus 1 for each of the time. Yeah. So else if the grid row and column equal to 0, so I just need to append the obstacles instead of a plus 1. And for here, I need to check if this r equal to r minus 1 and c equal to c minus 1. This means I've already found it. Yeah, because for each of the time, these obstacles must meet the conditions, and I will check it later. So we're gonna return the number of the steps. Yeah. Yeah, if we cannot return the number of steps, so finally we're gonna return a -1. But I don't think this is right. Yeah, because the obstacles can even exceed this value of k, because we didn't control that. So it means if we want to let the obstacle plus 1, we have to check. Yeah. So if obstacles plus 1 less than and equal to k, so we want to put it inside of the queue as row column obstacles plus 1 and steps plus 1. Yeah. So else we're gonna just put it inside. Yeah. So in this control, we just make the obstacles less than or equal to k. Yeah, because if we were to put it inside of the queue, it must be less than or equal to k. Let me check about these areas if this is okay. Yeah, because if this is not inside the weighted set, so definitely we want to put it inside. Yeah. But for the Q, we have to check. If this is an obstacle and the obstacle plus the 1, it means we want to update the obstacle. The obstacle would be plus 1. If we want to put it inside the Q, we have to check if it meets the conditions. So the condition is that it should be less than or equal to k, and then we want to put it inside. Yeah. So if this grid row and column equal to 0, so definitely we are safe. We don't need to do anything because the obstacles always meet the conditions, and anyway the steps would plus 1. Yeah. I think that is all for 048. Maybe the weighted set is just coming from here. But this is okay because inside the weighted set, we always want to keep the obstacles less than or equal to k. So from here, I think we are also safe to put the weighted set as it is. Just put it here. Yeah. Now let me just run it to check. As you can see, it works. Now let me submit it. As you can see, it passed all testing cases. I think it's pretty fast. And the time complexity is dependent on this state of the weighted set. So it's going to be 0, 0, and another 0. So it's going to be n cubic. So mn is just 40. So that means why it is so fast. Yeah, I think that's for this problem. Maybe you think why I should prepare a weighted set with 3 dimensions. So what if you only prepare 2 dimensions? You're going to make a mistake. So you only have a 0, 0 as your start position, and then from here you just put the row and column inside your weighted set. So what's going to happen is that you only prepared a position. It means if you visit this cell, you can never visit it anymore. But the problem is that we have obstacles. At this cell, it can be visited many times. And at each time, it's going to have a different state. And the state is dependent on how many obstacles you have. So that means we have to prepare 3 dimensions instead of 2. So now we have 2 dimensions. Definitely you're going to make a mistake. Let me just check here. Fix the typo. Yeah, it is not. I didn't make a mistake. I don't know why. Oh, there's parentheses. I deleted more parentheses. Yeah. Now let me submit it. You know it cannot pass because this is not right. So the problem is that you cannot visit each cell only. Yeah, but anyway, it should not work because here should be row and column. I need to change it from here. Yeah. Now I think at least I can pass some testing cases, but not instead of the memory exceeded error. Now I passed more than 50 testing cases, but this is wrong. Yeah, because we need to have 3 dimensions. 2 dimensions is not enough. Because we have obstacles, we need to have another dimension to record the number of obstacles. Because for obstacles equal to 1 and equal to 2, it can be at the same cell, but it can have the different result. Yeah, so this is why even we want to go to the bottom right corner, this cell, and we also need to have record the number of obstacles. Maybe the obstacle is 0, we are safe. It is 1, it's also okay. But why we are using the BFS, we always get the shortest path. That is why we can return the steps immediately. Now let me just recover, make it to 3 dimensions, and everything should be okay for the problem. Yeah. Now we have 3 dimensions, and let me run it and submit it to check. Yeah, as you can see, it works. And I think that is only the difficult part of the problem. If we understand that, basically this problem is going to be a medium problem. Thank you for watching. See you next time.